Hi, everybody. We're starting. We're doing a section 1.3. Now we're not going to do the entire 1.3. I'm just going to do part of it. But let's get rolling here. So here we have section 1.3, which is applications, which is basically just applications of some of the stuff that we learned in chapter 1. So I'm not going to do the whole thing. I'm just going to do just one problem, just to give you the idea. There's something called polynomial curve fitting, which is a very useful thing. You take data points and you figure out the polynomial that goes through them as best as possible. Now, in general, whatever number of points you have, the degree of the polynomial will be one less than that. So here we have example 1. We have 3 points. We have 1, 4, 2, 0, and 3, 12. And therefore, the polynomial we're going to get is 3 points. So the polynomial is going to be a second degree polynomial, which, as you know, the graph of that is a parabola. And we want to find the coefficients of this quadratic, the a0, the a1, and the a2. Those are the coefficients of this polynomial function. So we're going to use the points 1, 4, 2, 0, and 3, 12, and basically we're going to plug in x equals 1, and we're going to get a result of 4, x equals 2, get a result of 0, x equals 3, get a result of 12. So when I put in x equals 1, I get p of 1 is equal to a0 plus a1 plus a2 times 1 squared, whatever, which is just a1 plus a0 plus a1 plus a2 equals 4 pow. That's it. And that's my first linear equation. My next linear equation is going to come from taking. That's interesting. I'm plugging points into a polynomial, but the squares are the constants. It's kind of weird in a way. It's like the x was started out as a variable and the a's started out as the constants, but now I'm kind of going to, now what's happening is that the x's are kind of becoming constants because I'm plugging constants into them, and the a's are becoming sort of the variables. So I get a0 plus 2a1 plus 4a2 equals 0, and then when I plug in x equals 3, oh, where'd I get the 0 from? The 0 came from the point 2, 0. Now I plug in x equals 3, I get a0 plus 3a1 plus 9a2 equals 12. Where the 12 come from? Because the point that I had was 3, 12. Now I have 3 equations with 3 variables. As I'm just looking at this part right here, it's 3 equations with, this is 3 equations with 3 variables. And the book just tells us that these are the answers. a0 is 24, a1 is negative 28, a2 is 8. And the polynomial function is p of x equals 24 minus 28x plus 8x squared. What the book doesn't tell us is how they got this solution. So let's figure it out. Boing. So here we go. When I took the equation a0 plus a1 plus a2 equals 4, well, that corresponds to the top row of my top matrix, 1, 1, 1, 4. In other words, I'm taking these 3 equations and I'm converting them into the system of 3 equations, and I'm converting it into this augmented matrix. I also had a0 plus 2a1 plus 4a2 equals 0, and that became the second row of my matrix. And the third row is, as you see, 1, 3, 9, 12. So I'm going to do, and normally it's a little hazardous to do two operations at once, but I could do that here. I can get away with it because the 2 operations are independent of each other. They won't interfere with each other. So I'm going to do negative R1 plus R2 becomes my new R2, and then negative R1 plus R3 becomes my new R3. And now I have my second matrix, 1, 1, 1, 4, 0, 1, 3, negative 4, and 0, 2, 8, 8. And now I'm going to do another operation, negative 2 R2 plus R3 becomes the new R3, and that gives me my third matrix, 1, 1, 1, 4, and 1, 3, negative 4, and which, notice those top 2 rows are the same. It's only the third row that changed to be 0, 0, 2, 16, and now I'm going to let 1/2 of R3 become my new R3, so the top 2 rows stay the same, but the bottom row becomes 0, 0, 1, 8. And this right away gives us a solution, 24, negative 28, and 8. Why is that? Well, if you remember what this represents, you know, this represents this matrix, this last matrix represents a system of equations. Now I'm going to take this bottom matrix and just write what the equations are, and those equations are, I have it here somewhere. I have it here somewhere. Oh, where'd it go? That's these guys right here. So that last matrix is the equation A0 plus A1 plus A2 equals 4, A1 plus 3A2 equals -4, and A2 equals 8. Well, I have A2 equals 8 that from the last equation. I'm done. Once I know A2 equals 8, I plug that into the second equation, and I get A1 plus 3 times 8 equals -4. A1 plus 24 equals -4, subtract 24 from each side, I get A1 equals -28. Well, once I know that A1 is -28, and I know that A2 is +8, I just plug those two things into the top equation, and I get A0 minus 28 plus 8 equals 4, and just bring everything over to the other side and get A0 equals 24, and that is where the solution came from. This is just one example of many applications. But my point is like this, or a side point I want to make. When you see an application problem, sometimes it's like very scary. You know, it looks like this complicated application. Maybe, but the actual mathematics of it wasn't so, horrendous. It was really just the same stuff we've been doing for the entire chapter 1. So never be afraid. Just do the math and you'll be great. You'll be fine. Anyway, that's all I want to do for section 1.3. The next time we meet, it will be on chapter 2, which is where the real fun begins. Okay, everybody, we'll see you soon. Bye.